Hello guys, so today I'll be solving this problem. So the problem states that count special triplets. Okay, so it states that we have been given some array, let's call it a1, a2, some an. Okay, and the definition of special triplet is, so we need to select three indices. Okay, I, j, k. Okay, and I should be less than j should be less than k, and k should be less than n, and I can be greater than equal to 0. Okay, these are the condition, and the numbers that they hold, nums of I. Okay, it should be equal to 2 times nums of j. Okay, and similarly nums, it should be equal to nums of k. Okay, so we need to figure out how many total number of special triplets are there in the array. Okay, number of special triplets. Okay, so this problem is a implementation type of problem. Okay, where we just need to do what the question has asked. Okay, there is not much to do it. Okay, so a trivial approach, like I think this approach will come to your mind at first. Okay, so it's basically like for every indices, let's say a1, a2, a3, some, let's say some a of I. Okay, and let's say some a of n. Okay, so you can like fix your index like that you need to find. Okay, let's say I want to get my count for every jth index. Okay, so with that, what you can be doing is you will be iterating over your j. Okay, since j should be greater than I. Okay, you will be starting j with 1. Okay, j less than n. Okay, and j plus plus. Okay, then for every jth index number, let's call it le. Okay, le. So what you will be doing is, how many elements, okay, let's call it a of j, how many elements, okay, to the left of my jth index, okay, are 2 times le. Okay, and how many elements to the right of j, okay, are equal to 2 times le. Okay, let's call this thing as my suffix count. Okay, and let's call this as my prefix count. Okay, so if you go by this approach, okay, and let's say you have figured out like how to get the counts of the elements. Okay, then a naive approach will be, let's increase our answer. Okay, a naive approach will be, for every element that you have visited, if you are denoting that element as your jth element, then you will simply increment your answer something like this. So let's call the prefix count of your 2 times le times suffix count of 2 times le. Okay, and you will be doing a overall mod here. Okay, because the question is saying like we have to do a modulus. Okay, so this approach will work. Okay, and how you can get the prefix and suffix count, so that is also simple. Okay, so you need to modify this loop a bit, and the way to do that is, so first you will be building the suffix count. Okay, so in order to build the suffix count, first you need to get the counts of all elements that are present in the array. Okay, so for that you can use a map kind of a data structure. Okay, like for C++. Okay, or dict in Python. Okay, or unordered map will also work, but to make it more efficient, okay, because in unordered map and in map data structure, okay, the time complexity for searching and updating elements, that's like log n. Okay, and for unordered map, okay, it can go to n. Okay, or the size of your map. Okay, so yeah, so if you notice in the problem, okay, and look at the constraints. Okay, the constraints are given like the nums of I are only varying between 0 to 10 to the power 5. Okay, so we can use a vector, okay, or a array, okay, as our counter. So with that, the time complexity for updating the counts will be constant, which is much better than your map and unordered map. So you can use a vector instead. Okay, so how you will be building a suffix array and a prefix array, I think it will be best if I show you in the code. Okay, so what I will be doing first is, so I'll be taking the count of elements. Okay, so let's say n nums of size. Okay, then I will be building my prefix and suffix count. Now what should be size of my vector? Okay, so I'm seeing when I'm using it, I'm doing a 2 times LE check, right? So how many times 2 times LE has appeared to the left of my jth index? So we can pick the size as the maximum element that is present in my array. Okay, the max of your nums. Okay, we can do a +1 here and a 2. Okay, so this can be the size of our prefix and suffix array. Why we did that? Because we are doing a 2 times LE, right? So it might happen if we simply initialize our vector, okay, to the max of the elements. Okay, 2 times LE will overflow the array size. So yeah, it's better to choose a safe index or a safe size. So yeah, I'll be choosing this. So first, yeah, I need to calculate what's the or like I need to find what's the maximum element present in num. So for that I'll be doing max, or let's call it size. Okay, I'm doing max element in nums begin, nums end. Okay, so this thing will give me the maximum element present in my nums. I'll do a 2 times here and a +1. Okay, cool. Now this will be size of my suffix and prefix array. So I'll be initializing them. So prefix will be sg and suffix will be sg. Cool. Now to build your suffix array, first you need to store all the counts of the element. Okay, so for that I'll be iterating over all the elements. So le nums, and I'll be update my suffix as le ++. Okay, now yeah, I will initialize my answer also. So here the thing is, so we need to do this modulus. So it's safe to do a long. Okay, so that it might happen like when you are adding this up in your answer, it might overflow. Okay, so I will initialize my answer and this unit as long. Okay, so I'll define long here. Okay, and I'll define my answer as 0, and I will define my modulus as 10 to the power 9 plus 7. Okay, now I'll be running this loop. Okay, so for that I'll be doing j starting from 1, and j why starting from 1? Because if j is 0, there is no way I can get a I which is like less than 0, right? So I'll be starting with j equal to 1, then I'll be iterating like 1 to n. N is the number of elements, and j ++. Okay, and then so since I have already like visited the first element, okay, so what I will be doing is I'll simply subtract the count of my first element from my suffix. Okay, so I'll do suffix of nums of 0 minus. Okay, and since I'm starting from here and I have already visited the first element, I will increment the count of nums of 0 to ++. Okay, cool. Now in this jth loop, when I'm visiting the jth element, okay, I don't need to include that element count, right? So I'll again do a suffix of nums of j minus. Okay, so that count will get removed. Okay, now I will increment my answer. So answer will be ans plus my prefix of 2 times of nums of j, okay, times suffix of 2 times of nums of j. Okay, and after that I will do a modulus. Let's keep it here. Okay, and since I'm visiting this element, I will increment the prefix count. Okay, and yeah, and finally I can return my answer. Cool. It failed for one case. I don't know why. Let's check. I'm giving 2. It should be 1. I'm subtracting my suffix count. Like I have visited this element, so I'll be removing that. And yeah, I forgot to increment it. Yeah, cool. If I run this, okay, all test case pass. Now I will submit. Cool, it got accepted. Okay, but I know, okay, but if you look, okay, so what we did here is, first of all, we find the size of my prefix, right, which is like the maximum element present in the nums. Okay, so that's a big O of n operation, right? Cool. Then we build our suffix array. Okay, and that's again iterating over all the elements, right? So again big O of n. Okay, then again I'm again iterating over 1 to n elements. Okay, I'm again touching the elements again, right, in a and touching them once. So again a big O of n. So the overall time complexity will be big O of 3 times n, which is great. Okay, which is good because you are in linear time complexity. Okay, and as per space complexity, okay, so we are using this max count, right? So and I'm creating 2 arrays for that. Okay, these are my 2 extra spaces. So this will be big O of max of element. Okay, like 2 times max of element, which is same as big O of max. Cool. So this is my time complexity. Okay, which is pretty good. Okay, and we can see like we are in between of this latency chart, but yeah, as I told, never trust this, but yeah, we are big O of 3n, which is good. But let's say this problem you came across this problem in an interview. Okay, so the interview will challenge you, okay, to do lesser than 3 looping. Okay, so how you can do that? So in order to do that, I was like, so I have done this problem earlier. Okay, and this problem is pretty simple, like pretty similar to what this problem is asking. Okay, so now let's look at this problem. Okay, so here the problem is saying that given a string, okay, that is formed by ABC. Okay, we need the count of all the subsequences ABC that are present in the array. Okay, so this problem I will give the link of this problem in the video description. You guys can check it out. But yeah, this problem is pretty similar to what we have been given here. Okay, so there the problem statement is, so let's say I have been given a string, let's say A B C. Okay, I need to find the number of subsequences. Okay, number of subsequences such that number of subsequences that are equal to ABC. Okay, let's look at this problem. So if I look at this problem, so here the answer will be what? So let's say I have this ABC. I put the indices 0, 1, 2, 3. So one possible combination is when A is at 0 index, B is at second index, and C is at third index. Okay, then another possibility is when A is at 1 index, B is at second index, and C is at my third index. Okay, cool. So this is a possibility. Now how we can solve it? We can use the similar logic that we put here. Okay, which is this so what we can do is, so we can simply iterate over all the characters in the string. Okay, now whenever C is let's say when C is equal to B, okay, we will simply, let's say I have this ans. Okay, we'll simply multiply the number of times I have seen A on the left of my current character. Okay, count of A. Okay, times the number of times C is there to the right of B. Okay, so count, I can say suffix of C. Okay, so we can put the similar logic that we use to solve this problem here also. Okay, but there is a pretty good approach, okay, to solve this problem, which is a DP approach. Okay, so the idea here is, so I need to find ABC count, right? Okay, so if I divide it into prefixes, okay, so if I know the number of times A is appearing, okay, let's call it count of A. Okay, so that can help me to get the count of AB. Okay, and count of AB can help me to figure out what is the count of ABC. Okay, so if I put this here, so count of A, I'm saying how many subsequences, okay, are there in the string. Subsequences are there in the string which are equal to A. Okay, now this count I can use whenever, let's say if I'm iterating over the string, okay, and whenever I encountered my character as B. Okay, now whatever count of A I already have, okay, that I can use to get the count of ABs I can generate. Okay, so I'll simply increment the count of AB with the count of A. Cool. Now again, now let's say when I'm iterating, okay, there I encountered C. Let's say my current character is C. Now I can use the count of AB, okay, to calculate how many number of ABCs I can generate. Count of AB. Cool. So you can see like so with this DP kind of a statement, so if I write the pseudocode, so it will be something like, let's initialize my DP as, let's say, some map kind of a data structure which stores like string to their count. Okay, so if I simply loop over this string, so this will be for C in S. Okay, so I can write if C equal to A. Okay, I'll increment DP of A count to +1. Okay, else if C is equal to B, okay, that means I can increment the count of AB to the number of A I have already encountered to the left of this character. So that will be DP of A. Okay, similarly, if my current character is C, okay, I can increment the DP count of ABC to the number of ABs I have to the left of this C, because those can pair up with this C and generate ABC, right? So this will be DP of AB. Cool. So yeah, we can use this kind of a DP approach to solve this problem, right? The number of subsequences, like the total number of ABC subsequences present in this string. Now this problem is pretty similar, because if you observed here, what we are doing is basically we are finding triplets which are in this form. So let's say for my jth element X, okay, I need to figure out this triplets. Okay, so if I simply replace this, okay, this with my A, this with my C, and this with my B, okay, I can apply the DP solution that I used for this problem to my current problem, which is this count special triplets. Okay, so let's say how we can do it. Okay, so what I will be doing is, so in this problem, let's say this ABC problem and this triplets problem. Okay, so the count of A, okay, for that I'll be storing all the elements count. Okay, so I'll be needing a counter. Okay, counter for my X. X is the element present in the array. Now to store the count of AB, which means this 2x and x pair that I have. So for my current element x, okay, how many times I have encountered 2x to the left of it, okay, that for that I can simply use another counter, let's call it counter 2, okay, and there I'll be storing the number of times I have seen 2x, okay. Then now similarly for here, the final answer is the count of ABC, right? So here I can simply designate my answer variable here. That means I'll be incrementing my answer with a counter of 2, okay, and this counter of 2 will be getting incremented by counter of x, okay. So yeah, so the idea here will be, so I will have two counters, so I can use the same prefix and suffix. I can rename them, okay. Let's say I have this counter 1, okay, okay, and I have this counter 2, okay. So I'll be iterating over all the elements, okay. So for LE in nums, okay. So for my current element, okay, so if I'm saying this guy is C, okay, so C as in this problem, okay, then that means I need for my current element how many LE and LE by 2, okay, I have encountered in my past, okay. So for that I'll be incrementing my counter with my counter of 2, okay, because that guy will be storing the count of this pair, okay, counter of 2 of LE, okay, because for my this triplet, like which is 2x, x and 2x, okay, my current element will be acting as my 2x, okay. So if my current element is acting as 2x, that means I need to find the number of LE and LE by 2 present on the left of my current element, okay, and that count is getting saved in my counter of 2, okay. Then I'll update the counter 2, okay, with the number of times I have seen 2 times LE, okay, with the number of times I have seen it in counter of 1, okay. So this is pretty similar to storing counter of like the count of AB, okay. Then finally I'll increment my count in counter 1 of LE plus plus. So yeah, with this my answer will get incremented with all this special triplet counts. So yeah, that's the idea. So I think if I code it up, you guys will have a better idea. So let's code it up, okay. So here instead of prefix I will use a counter 1, or let's call it finder x, okay, and for suffix I'll be using finder 2x, okay, cool. Now I don't need this suffix, okay, and my answer and mod variable will be there, and I don't need this updation, okay, and I don't need this n also, the number of elements, okay. So once I find the size of my arrays, okay, then I can simply iterate over all the elements, okay. And what I will be doing is, first I will increment my answer with finder of 2x. So when LE is acting as my 2x, okay, cool. Then I'll update the 2 times LE count or the 2x count in finder of 2 with the number of times I have seen it in finder x, okay. So this will be 2 times x, or instead of using LE I can use x here, okay, cool. Then finder of x will become I'll simply increment this, because for the current element, so for the current element count, I'm storing it in finder of x. Okay, so the finder of 2x is basically storing how many times I have seen the twice of this element to the left of it. Okay, so that count I'm incrementing with my counter of elements. Okay, so yeah, that's the idea. Now if I run it for all test cases, cool, all test case pass. Now let's submit. Cool. Now if you see here, okay, so if you look at the time complexity here, so in order to find the maximum element, we are doing a loop. Okay, and to get my answer or to update my answer, I'm iterating over all the elements again. So that's a big O of n. So we have reduced from big O of 3n to big O of 2n, which is kind of the optimal solution for this problem. The prefix suffix solution works. That's also linear time. But in interview kind of a situation, the interviewer will ask you to reduce down the time complexity. That's why we did it. Otherwise, the suffix and prefix count, like the first thing that will come to your mind, just go with it. Okay, that's a great solution. Then the space complexity wise, again the same thing. Big O of maximum element that is present in the nums. Cool. So this was for C++. Now let's do it in Golang. Okay, so I need to find the maximum element. So for that I'll be using slices. Okay, so that will give me the maximum element present in nums. So I'll do slices of max of nums plus 1 here, and 2 times this. Actually 2 times maximum element plus 1 will also work, but yeah, let's do the overall. Cool. Let's decrease this. Cool. Now I need to create my counter 1 and counter 2, or like I can say finder x and finder 2x. Okay, so I'll be creating finder of x as make of okay, and since I was I will be doing the multiplication. Okay, so Golang has this type-based system where you cannot multiply an int and int64, so I'll be storing it in int64 because I will be creating my answer as a int64 variable. Int64. Okay, and I need to create my mod variable, so that will also be in int64, and I will initialize to 10 to the power 9 plus 7. Okay, and yeah, so I will create this and I will say this is of size this. Then finder of 2x will be again make of int64 of size C. Cool. Now I'll simply iterate over all the elements. So le range nums. Okay, so first I will increment my answer with the number of times I have seen AB, or you can say 2xx. Okay, to the left of my current element. Okay, when my current element is acting as 2x. Okay, cool. So I'll do a mod here. Okay, then I will update the 2x count for my twice of element, or let's use x here. Yeah, x with the number of times I have seen it in finder x. 2 times x, and finally I'll be incrementing finder of x with the count of x. Like I'll be doing plus 1 here. Cool. And yeah, after that I'll be returning ans. Cool. Now ans will be int 64. I'll need to return int, so I'll be doing a typecasting here, and yeah, cool. So running for all test cases. Now it failed because x here is int. Is that the case? I don't think that's the case. Cool. If I submit this, cool, it passed. Now the time complexity is same as our C++ solution, and yeah, so let's finally do it for Rust. Cool. So in order to find the size, I'll be doing 2 times of the maximum element present in nums. Now in order to get the maximum element present in nums, I will be doing nums of iter of max. Okay, so this will return option. I will be doing unwrap. Okay, and yeah, this will be a pointer, so I'll say I will dereference it, and I'll be doing a +1. Now this will be giving me I32, so I need to convert this guy to a U size, because yeah, my size should be of U size so that I can initialize my arrays. Cool. Now I'll be creating my counter 1 and counter 2, or finder x and finder 2x. Finder x, so that will be vec of and yeah, these will be of vector of size I64. So the same logic as Golang, okay, because type checking is like it's pretty like C++ is lenient, but type checking in Rust and Golang are like difficult, like they are more forceful. So yeah, vector of this, so I will initialize to 0, and then I will do size, then the same thing I can write it here for 2x. Cool. So yeah, I will also initialize this, then I will initialize my answer as 0, and I will initialize like as I64. Then similarly I will do for my mod. For mod I will be using capital this. I will be doing this snake case notation for 10 to the power 9 plus 7. I will be doing I64 of it. Cool. Now I will be iterating over all the elements. Let's call it x in nums. Okay, first I will be incrementing my answer, which will be ans plus the number of times I have seen 2xx when x is acting so when my current element is acting as 2x, so finder of 2x of x. Okay, and mod of this, mod of this. Cool. Then I'll be updating my 2x counter with the twice of this element, and yeah, this element will be of type I32. So what I can do is I can do le here, okay, and I can write my x as le as a U size. Cool, because I'm using these elements as indexes, so that's why. Cool. So here I'll be incrementing my 2x counter with finder of x of 2x. Cool. Now I'll be incrementing my finder of x plus equal to 1. Cool. Now if I run it for all test cases, it should work. Okay, it didn't work because this is of I64. I will convert it to I32. Cool, all test cases pass. Now if I submit this, it got accepted. So time complexity same as what we did for C++ and Golang. So yeah, that's the idea. So yeah, so to do a recap, so yeah, the prefix suffix solution works, okay, but in order to do it in 2 times of linear time complexity, okay, so you can check out this problem, the number of subsequences problem, okay. So I think that will give you a better idea, so how I'm mapping that problem to here, okay, and the idea is pretty straightforward after that, okay. So we are just storing like how many times we have seen 2x and x for every element, and because that time we are like at this time we are considering the element as my 2x, okay. So in order to get the previous counts, okay, so I need this count which I am storing in a different counter, which is this finder of 2x. Now in finder of 2x I'm simply incrementing the count of 2 times x, so because this guy is capturing the count of every element, so yeah, I'll be updating with that, and finally I'm updating the counter of every element. So yeah, I will give the link of this problem in my problem description, so you guys can check it out. And yeah, if you like the solution and you learn something new, please subscribe to the channel, and you can post a comment if you have any doubts, okay. I'll be happy to answer it. So till then, just stay tuned, and bye bye. Thank you.